Yes, I welcome you once again to our class. Since you told me that there was nothing like a challenge that you got, that is good news, and I hope that everything goes on well. Yes, we're still looking at bearings. We're still looking at bearings. What we had last time, a reminder of what we had last time, we introduced ourselves to what bearings is, and we say that bearings is all about telling a direction, or telling the direction of a given region with respect to another. In other words, for example, it may be in Kampala and another one is in Muko, and someone wants to be directed to a given place. So you can either use a map in addition to bearings. In other words, a bearings is applied, just like we saw last time, among others. But the most important thing here is telling the direction. We said last time that of representing bearings. There are two ways of representing bearings. Bearings and then the true north bearings. We gave an example, for example, this review. We said that two ways to tell bearings. One of them is using the compass bearings. And then another way we say there was the true north bearings. True north bearings. And on this one here, we had an example. For example, in case you have a town O, and then one may ask that, what is the bearing from O? What is the bearing? What is the bearing of A from O? We say that when you are trying to read what you call bearings, always pay much attention to what comes last. That is what someone told us last time. That you always pay much attention to the last point. In other words, look at the word from, and that is where you draw your compass, like this. So in case you have your town A, then you simply join using a straight line. Now, assuming that, for example, this angle is 30 degrees, like that, you can either use what you call the compass direction method of reading the bearings, and you say that one of the ways of reading the bearing of A from O is north 30 degrees east. In other words, you start from the north. And then you move towards the east. That's what we said. Or you can use what you call the other method of reading bearings, and that is the true north bearings. Or simply read expressing the degrees in 3 digits, or using 3 digits. Or you can simply say, or you can read the bearing of town F from O as 030 degrees. So that is what we talked about last time. Another example of doing this, another example of reading bearings from a given point, we said that, for example, in case you have 2 towns again, you have town O and then your town T is at that point there. What is the bearing of town T from town O? Still, you pay attention to the word from O. In other words, the last point. So you draw your compass direction at that point, and then assuming that this line here is making an angle of 20 degrees, like that, bearing of town T from town O. So still here, there are two ways. There are two ways. You can simply use the compass bearing method. In other words, if you're using the compass direction method, you always measure the angles starting from the north-south line. North-south line. You always begin from that. So let me ask someone, anyone, what is the angle between these two? The angle represented by the red, this one here, angle theta. Anyone?
70 degrees.
70 degrees. How have we got it?
90 minus 20.
90 minus 20. That is very good. In other words, we know that if you have right angles like this, 90 degrees, 90 degrees, 90 degrees, 90 degrees. When you add up all of them, you get 360 degrees. So if this is 90 degrees, then it means that in order for us to get this angle here, you simply need to get 90 minus 20, and then you get 70, like she has said. So if this angle here is 70 degrees, like that, using the first method of reading bearings, you can write the answer of bearing to the question bearing of town T from O. You can write it as south because this is south, this is west, this is east. So south 70 degrees west, like that. That is one way. That is using the compass bearing method. So you simply write, you measure the angles from the north-south line. So, and then you add the degree, the angle there, and then either east or west, you add that one there as well. In other words, when you're using this method here of reading the bearings, it means that you're beginning from the south, you measure 70 degrees going to the west. That is what it means. Or using the true north method, true north bearing method, you simply measure the angles from the north up to when you reach that direction there. So on that one there, of course, we know that angles on a straight line add up to 180, but then you add on the 70, and you get your answer as 250 degrees. So you can simply read our bearing as simply using the 3 digits as 250 degrees as our bearing to that. So that is what we have is speed. Anyone remind us from and then you talk. How do you define speed? We're going to introduce it into our calculations, the coming calculations. So I'm going to combine some bit of motion, that is speed, distance, time, and bearings. But before I do that, I need someone to define for us the term speed. How do you define speed? Or what formula do you use to calculate speed? Yes, anyone, you can unmute yourself and then you say it out.
Speed is distance out of time.
The formula for speed is distance out of time. Very good. It is equal to distance out of time. Very good. Okay, in case you remember this formula, but remember the definition, I can help you on the definition. Of distance. Yes. Someone say next, please.
Is it okay if, like, I wrote speed is the coefficient of distance and time? Sorry, not coefficient. Quotient.
Hey, no, when you say the quotient, yes, I will mark at that. I'll mark that. But of course, in mathematics, I'm not going to ask you to define. There's no definition in math. But of course, you must know what define speed as the rate of change of distance. The rate of change of distance. In other words, get distance divided by time. That's what you have as speed. And still, from this formula again, I can simply get all the others in case I draw a triangle like this. I know you had a triangle like this in your primary, where you had, for example, speed, distance, and time. So from this triangle, you can see that your speed is equal to distance out of time. Then you can also say that distance is equal to speed times time. At the same time, you can say that your time is equal to distance out of speed, like that. In other words, in case they've given you distance and time, you can divide the two and get the speed. In the case of being given the speed and the time, you can multiply the two and then you get the distance covered. At the same time, when you've been given the distance and the speed, when you divide the two as shown there, you can get the time taken. We shall look at this more in physics. It will be in senior 2 physics. But at the moment, what I need you to remember is at least this formula here. That speed is always equal to distance divided by time. So that is what you're going to be looking at as far as bearings is concerned. Some distance. In other words, we're going to tell the exact position of a given. That is what we're going to be looking at. So I need you to write this from where we stopped last time. Let me first pause here. Few expressions there. You can have this example. Some example. So very and the two towns are 15 kilometers apart. I represent the information on Scale diagram means that you're going to draw on the graph paper. You're going to come up with an accurate diagram. You're going to come up with an accurate diagram. Okay. So what you're going to do here is very simple. We're going to draw a sketch first. You want to draw a sketch first? And maybe before you draw the sketch,
Excuse me, teacher, I can't hear what you're saying.
I can't also hear what you're saying.
so since you're through with the sketch, you must be having a protractor, you must be having a ruler, and then a divider, a compass, but not so much there. At least must be having a protractor and a ruler. So we're going to draw our accurate diagram. So the first thing to do is to locate where A is. So use a compass, a protractor, and you draw where A is. So this is point A. So after drawing this horizontal line here, after drawing this horizontal line, you put a protractor there like this. You put a protractor there like this, such that this line here is at 90 degrees. This is 0, 180, and then 90 degrees. So you first draw this point, and then afterwards you connect. Let me repeat the same. I'm saying that you're going to first draw a horizontal line like this, and then you mark a point here. You mark a point there. Then afterwards, you put your protractor like this, such that that horizontal line is on the line along the 0, 180 degrees line. And then after that, you mark off a point at this point here, which is going through 90 degrees. Once you're done with that, then you draw your north direction like that. Of course, after removing the protractor. So once we're done with that, we can then say that we have our town A at this point. This is town A or village A. Village A. Let's do that as I'm waiting for you. After you've done, replace the protractor and make sure that here you have 90 degrees. You first make sure that it is 90 degrees. If it is not 90 degrees, then you repeat. You repeat.
Yes.
Okay, yes, we are done. So the next step now is to draw our line which makes 75 degrees or to the north-south direction. So what we're going to do is our protractor this time around like this. Like that, such that, let me draw a better diagram here. We are going to draw, we're going to place our protractor on that line there like that. Okay, let me remove this. Let me remove this smart detection here. So our protractor is going to be like this, such that here we have 0 degrees, here we have 180 degrees, and then here we have, on this line here, you have, it is going through 90 degrees. You first make sure that it is bisecting it like that at 90 degrees. Then afterwards, from this 0 here, you're going to move to the clockwise direction and locate where you have 75 degrees. Remember measuring the angles from the north-south line. So once you have done that, once you have marked that, then remove the protractor and then you draw a long line going through like this. Going through like that. Of course, you first mark a point A and then a mark where your 75 degrees is. Then after that, you remove the protractor and then you draw your straight line. You draw a straight line. Okay. Before you do anything else, you replace the protractor and make sure that you have actually drawn 75 degrees. In other words, this point, this direction here, this angle here must be 75 degrees. If it is not, then repeat until you are doing a scale diagram. It must be a natural diagram. So still when you're done, you let me. So next, we are going to locate where B is from A. In other words, what distance is B from A? We said the question says that it is 15 kilometers. But then they said that 2 centimeters represent 15 kilometers. So my question is, how many centimeters are we going to draw to represent the 15 kilometers? Sorry, if 2 centimeters represent 5 kilometers, sorry. If 2 centimeters represent 5 kilometers, the question says that we're going to present on a scale diagram when we have B from A having 15 kilometers. So how many centimeters should we draw to represent the 15 kilometers? That one is now for you to try out. First, think of how many centimeters you're going to draw, and then we proceed together. you let me know of what you've thought about. What do you think? How many centimeters are you going to use?
Teacher, centimeters.
7.5 centimeters. How have we got that?
By getting 15 kilometers, by getting 15 divided by 2.
15 divided by 2. Okay, Rodrigo said the correct answer that we're going to use 6 centimeters. Okay, so this is what we do. If 2 centimeters represent 5 kilometers, in the question we have 15 kilometers. You can see that I've put the kilometers on one side. So since we don't know how many centimeters represent the 15 kilometers, we shall use a letter to represent the centimeters. So if 2 centimeters represent 5 kilometers, then it means that X represents 15 kilometers. So you need to find the value of X. And I'm saying that on this side we have kilometers, meaning that everything on the left-hand side must be centimeters. So what you do, you cross multiply. And then say that 5 times X, 5 times X gives us 2 times 15, implying 5X is equal to 30. So in which they divide both sides by 5, divide by 5, the 5 cancels out, 1, 1, and by 5, 1, by 5, 6, implying that our X will be centimeters. So you're going to put a ruler from this point along this line, along that line, and measure of 6 centimeters, from 0 to 6 centimeters, and you make a mark. You make a mark at that point there, that at this point we have 6 centimeters, and then label that point B, like that. So once you've done that, then you can proceed and you answer this is the exact position where B is from A. So the next question, which was saying that find the bearing of F from B. Bearing of F from B. So the word from B is the last point. Draw a compass at that point. Then bearing of F from B, then you measure using a protractor, and then afterwards you add it to 180, and you come up with the bearing as per the question. Then you can also finally get the speed as the question is speed. I'm say that time. Our distance was 15 kilometers, divided by our time was 2 hours, meaning that our speed will be 7.5 or 7.5 kilometers per hour as our answer. But at the moment, I want you to try out this bearing and you tell me the answer before you proceed. The time is running. Let me wait for you. I beg your pardon?
195 degrees.
Yes, is it a bearing of F from B?
Yes.
$195 degrees. Someone has gone 195 degrees.
190.
Okay, let's wait for others and we see. That is the bearing. Okay, someone has said that 175, 195 degrees. Let's check our answer. What are you going to do? I'm going to simply use a protractor. You're going to draw a long line here. You place your protractor like this, so that this is at 0, this one is at 90, and then for the measure of this point here from that is 75 degrees. Since I'm the pair of B of F from B will be equal to 108 plus 70, which is 255 degrees. 155 degrees. So the answer, how we got that is our answer. For speed, speed is equal to
Excuse me, teacher, I can't get you.
I'm going to end with this. I'm going to give you an assignment, like I said, at around 3 p.m. And I just want you to remember this, that in case someone writes north 80 degrees east, someone writes north 60 degrees west, that this first part here means, it means that if you have drawn your compass direction, you have your north there, east is at that direction there. So you measure 80 degrees, you measure 80 degrees like that. Then if someone has represented this, it simply means that you're going to have your north is there, and then you have your line towards the west. So someone measures 60 degrees as he's going to the west. That is what it means. So from this point to the other one, you measure 80 degrees. From this to this, you measure 60 degrees. Likewise, if someone gives you a bearing of maybe south 25 degrees west, it is the same thing. It means that if this is your north, this is your south, then you're going to make, this is west, this is east, you're going to measure off 25 degrees from the south, 25 degrees from the south. So you always begin from the south and then you measure 25 degrees. Likewise, again, if someone draws, gives it S 25 degrees southeast, like that, you still know what that one means. You still know what that one means. So I'm going to stop there. We'll get an assignment at around 3. Otherwise, have a good day.